Okay, so today we are having the topic that is Dalton law of partial pressure. So he was a scientist who measures the partial pressure of mixture of gases. Okay, so he was a scientist and uh, he measured the partial pressure in the mixture of gases. So he basically measured the partial pressure. So there is a law and on his name that is Dalton law of partial pressure. Let me give you the concept of partial pressure. For example, we are having a three chambers, three chambers A, B, and C. Okay, and here we are having there is a pressure meter. Okay, to count the pressure. Okay, so for example, we are having three chambers. In one chamber there is carbon dioxide, second chamber there is nitrogen, and in third chamber there is oxygen. If we are combining these all gases, and these all gases are like this, if we are combining their all the pressure meter, okay, so these gases are non-reactive gases. Non-reactive, this is a main point, that these gases are non-reactive gases. What does it mean? It means that cannot react. We mix that, they cannot react because they are stable, they are having more kinetic energy. He actually find the partial pressure of the non-reactive gases like these, which cannot react with each other. Okay, if gases will react with each other, so this law will not follow. Okay, that's why there is a main point that he made the partial pressure of the mixture of gases, but the non-reactive gases. If I will be giving you the reactive gases too. For example, we are having one you can say the chamber, we are having hydrogen here and oxygen here. If we are combining them, so we are having a H2 plus O2, that will make a that can react with each other, and they will make a one molecule of the water. So you can say that they are reacting to each other and something product is making. So the reacting they will mix and react, and you can say that the liquid will got appear. So these are reactive gases which are reacting to each other and making a product. But he has a law which is act upon the non-reactive gases. Okay, so what is partial pressure? A single part in a mixture is called partial pressure. Means single pressure of any gas. If we want to find the partial pressure of carbon dioxide, if we want to find the partial pressure of nitrogen, oxygen, we can find, but separately. That is called the partial pressure. Single part and mixture is called partial pressure. Okay, they cannot react with each other because they are non-reactive gases. Okay, so we can find the partial pressure as well as total pressure. Total pressure, like if we are adding their all pressure, they will the total pressure will be appeared. For example, this carbon dioxide is having a 2 atm pressure, nitrogen is having 1 atm pressure, and they are having 3 atm pressure. So finding the, you can say that the partial pressure will be dividing in total. But let me give you the that is there is single pressure of their own gases, that is partial pressure. If you're talking about the total, so pt, that is total pressure, is equal to pco, that is partial pressure of carbon dioxide, partial pressure of nitrogen, partial pressure of oxygen. Okay, so pt is equal to 2 atm plus 1 atm as well as 3 atm. You can say that total pressure is equal to 6 atm, that is total pressure, and that was the partial pressure. Okay, so in the atmosphere we are having many gases like O2, CO2, N2. So so oxygen is having a high pressure in atmosphere, that's why we can breathe. So all gases have their own pressure, their own gases having their own partial pressure. Okay, they have their own partial pressure. So this Dalton laws appear on the non-reactive gases. Okay, non-reactive gases. If you're talking about the measurement of partial pressure on the basis of the ideal gas, oh, one thing is remaining. That is that this Dalton law is appeared on the ideal gases. Okay, ideal gases, not on real gases. We have done a huge concept and too many videos on ideal and real gases. You can watch it out that what is the difference between them. So this law is appeared on the ideal gases. Every law is appeared on ideal gases, as you can see that. Okay, so today we have made the partial pressure. So for example, we were having a partial pressure of carbon dioxide, which is we are having, first of all we are having an equation that is P is equal to nRT. That is a ideal gas equation. So P, partial pressure of carbon dioxide, and V, number of moles of carbon dioxide, and you can say that this is RT. You can write that. Okay, second, you can see that P is equal to N2, V is equal to N2 RT. Third one, P is equal to O2 V N O2 RT, number of moles. Okay, so you can see that pressure and number of mole are variable, and the constant are R, T, and V. They are constant because of the STP. Okay, so here you can see that we are having equation and we have just put it the value of the gases. This is equation 1. This is the equation of carbon dioxide, this is the equation of nitrogen, and this is the equation of the oxygen. If you have to find the total pressure, we can write here that PTV is equal to N. You can say that the PTV, total pressure, is equal to nRT. Okay, so nTRT. What is PT? That is total pressure. What is NT? That is the total mole, you can say. Okay, volume will remain constant. Volume will remain constant in every condition. Okay, so if you have to find the partial pressure, there was an equation. If you have to find the partial pressure, for example, we are having gas 1, gas A, and we are calling them PV is equal to nRT. If you're talking about gas A, so that is PAV, partial pressure of gas A, volume, N of number of moles of A, RT. Okay, if we are having for example gas number 2, B, that is PV is equal to nRT, that is ideal gas equation, and P of what? PBV NB RT. Okay, and if you find the total pressure, so we can write it PTV is equal to NTRT, total number of mole, total number of pressure. This is the total pressure, and this was a partial pressure equation. Okay, if you have to find the partial, you can say that pressure, so we'll be dividing by the total pressure. For example, if you have to find the partial pressure of a gas, so we will dividing by the total pressure. Like what? Like this, PAV is equal to NART, that is equation. This we have to divide by this, like this, PTV is equal to NTRT, that is total pressure equation. AV will be, V will be cancelled by V, RT will be cancelled by RT. So what's remaining? PA upon PT and NA upon NT. What is this? This is a mole fraction. Mole fraction, which is denoted by X. Here there is a gas which is A. So we can write here this is A. Okay. So PA upon PT is equal to XA. Okay. And we can write here that PA is equal to XA multiplied by PT. That is the partial pressure of gas A. As it is, we can find the partial pressure of gas B. We can find the partial pressure of these all by dividing the total pressure. Okay. If you have to find the total pressure, we will be adding all those, okay, equations. So today we are done with the Dalton law of partial pressure. In the next video, we'll be discussing about the application of the Dalton law of the partial pressure.